Today we are solving LeetCode 219 contains duplicate 2. This is an easy problem but it teaches a very important DSA concept. How to use a hash map to remember information while traversing an array. We are given an integer array nums and an integer k. We have to return true if there exist two different indices I and j such that nums I double equals nums j and else I minus absolute value of I minus j less than equal to k. Let me show you the problem. In simple words, we need to check whether the same number appears again within a distance of at most k. Let us understand this with the first example. So our nums equals 1231 and our k equals 3. So we see that 1 appears at a distance of less than 3. So distance less than or equal to 3. So distance between 1 and 2 is 1. 1 and 2 is 1 and 3 is 2 and 1 and 1 is 3. So that is less than equal to k, that is 3. That's the output is true. Now look at this example. Nums equals this value and k equals 2. Here duplicates exist, but the one appears at index 0 and index 3. Distance is 3 which is greater than 2. Similarly 2 appears at index 1 and index 4. Distance is also 3 and 3 appears at index 2 and index 5. Distance is also 3. So duplicates are present but not within distance k. Therefore the answer is false. The answer is false now. Now let us think about the brute force approach. For every index I, we can check every other index j. If nums I double equals nums j and absolute value of I minus j is less than equal to k, we return true. We return true. Simple. So for every index I, we check every other index j. And if nums I double equals nums j and absolute value of I minus j less than equal to k, we return true. But this takes time of O n square, which is very slow, as you can see the constraints. It is of the value 10 power 5, so it is very slow. The length is of range 10 power 5 and is of range 10 power 5. Since the array length can go up to 10 power 5, this is too slow. So we need a better approach. The important observation is this. When we are standing at index I, we only need to know one thing. Have I seen the same number before? And if yes, at what index? So optimal approach. So when we are standing at index I, we only need to know one thing. Have I seen this number before? And if yes, at what index? So we can use a hash map. The hash map will store number. So use a hash map and it will store number and each number will refer the last index where this number was seen. Now we traverse the array from left to right. For every element nums I, we check has this number appeared before. If yes, let its previous index be previous prep index. So now we check I minus prep index less than equal to k. If this is true, we found two equal numbers within distance k. So we return true. Otherwise, we update the latest index of this number to I. Why do we update? Because the latest index is always better for future comparisons. A closer previous occurrence gives us the best chance to satisfy the condition. Let us dry run. So nums equals 1, 2, 3, 1 and k equals 3. So start with an empty map. Index 0, value 1. So when we are at I equal to 1, I equal to 0, let this map be like this. So we store one value inside this hash map. At index 0, the value equals 1. So we store the number and its latest index. So number is my 1, that is nums I. Nums I equals 1. So our hash map will contain nums I mapping to I. Now for I equals 1. So nums 1 equals 2. 2 is not in the hash map, so we store this also. So first was 1, 0 and second one was 1 is 2 and its index 1. Then I equals 2. So nums 2 equals 3. 3 is not there in the hash map, so we store this value also. Then we get I equals 3. Nums 3 equals 1. Now 1 is there in the hash map. So we check if so nums 3 equals 1. So 1 is there in the hash map. So we check 3 minus 0. 3 minus 0 is less than equals k. That is equal to 3. So we return true. Now let us write the code. So initialize last equal to blank hash map. Then we run the loop. For I comma num enumerate nums. So what enumerate does is it breaks down the array with first value as index and second value as the value at that index. So it will have I comma nums I, these kind of values. So if nums in last seen, then we check the condition if I minus last seen nums less than equal to k, then we return true. Now the main point here is we can check this in order 1, last in nums. That is the point of storing this as hash map. This value can be retrieved in order 1 time or 1 time. Else if it is not there, then we update the last scene. Num equals I. Finally, if we run the complete loop but haven't returned, that means answer is false. So we create a dictionary called last scene. This dictionary stores the last index where each number appeared. Then we loop through the array using enumerate so we get both index and value. If the current number is already present in last scene, it means we have seen it before. Then we check the distance between the current index and the previous index. If this distance is less than or equal to k, we return true. Otherwise, we update the last seen index of the current number. Finally, if we finish loop and do not find any valid pair, we return false. Now time complexity is order n, O(n). So time is O(n) because we only traverse once. Space complexity is O(n) because in the worst case we can store all the values in the hash map. So this is the idea. Let us run the code and see if it passes. So the test case pass. Let us also submit and see if all the test cases passes or not. So yes, it passes. So this hash map techniques work. We can think on why does this work, because we are storing in the worst case we can store all the numbers inside last scene. So to search on this it will take some time, so it can maybe store them in good manner. So at that time it may not be order 1 but of order log n by doing binary search. But actually HashMap works a bit differently. uh, HashMap will in most of the cases HashMap will give me order 1 time because uh, the numbers will be of will not be the length of the array will not exceed 10 power 5. For example, my num size can although can go between minus 10 power 9 to 10 power 9, but this last string will not contain 10 power 9 different entries because it will be constrained by num dot length. Also, it is not very likely that all the nums dot length are different. So it can be the case that many of them are same and it will be much less than 10 power 5. So that's why the hash map will give me the time complexity order n most time. Also, there are some different algorithms which we are not discussing, which are made to optimize hash map. So it practically takes order 1 time. Uh, but if we are simply using a simple array and searching it um, after we have sorted, after we have stored them in a sorted manner, then it can take order log n time to search in the worst case. So it becomes order n log n instead of order n. Now let us discuss another algorithm that is by sliding window. So keep only the last k elements in a set. This is the key idea. Sliding window. Let me write it. So keep only the last k elements in a set. If the current number already exists inside this window, return true. Otherwise, add it to the set. If the window size becomes greater than k, remove the element that is too far away. So this is very simple. We just maintain a window in which we keep the last k elements. So let's write its code. Window equal to set. We initialize an empty set. So this is not a dictionary but a set. So in the set, order is not maintained. In a dictionary, order is maintained. For I, num in enumerate nums, we check this condition. If num in window, then we return true. So it takes lesser time to search in the set, maybe log k time if you do binary search. It internally maintains an order. Although if we want to get the first element of the set, so that can be anything. And if num is not in window, we add we add the num into window. And if my length of the window exceeds k, then we remove the last element from the window. So let us check the difference between dictionary and a set, just to be clear. So exact difference between dictionary and a set in Python. So the fundamental difference is that a dictionary stores a data as key value pairs, whereas a set stores unique elements. Okay. Both data structures leverages hash tables under the hood for efficient O1 lookup times. Okay. So first thing is that whether you use a dictionary or a set, the lookup time will always be O1. And second thing is that dictionary stores data as key value pairs. So every entry will have a key and second value as pair. While in a set, only single individual items are stored, and they must be unique. That's it. So every element must be immutable. Preserves insertion order, and it is completely unordered. Okay. So what we are doing here is window dot remove. We are removing this element nums I minus k. So if len of window is greater than k, then we find out what was the value k steps back. Then we remove that value from the set. That's it. So finally we return false if we are unable to return true even after completing the loop. Let us run this code and check. So both the time and space complexity will remain the same as previous solution. Because this lookup time, if num in window, this takes order one time. That's why time complexity is again order n, O n. This is also O1 operation, and this one is also O1 operation. And we are looping through the array only once. That's why time is O n. And spaces, because we are maintaining a set, so O n space is required. Let us also submit it. So it passes all the cases. So HashMap approach is usually easier to understand. The core idea of this problem is do not only check whether duplicate exists, check whether the duplicate exists nearby. So we need to remember the last index of each number. That is a complete solution for LeetCode 219 contains duplicate 2.